Triton is the first moon discovered around Neptune. It was discovered not terribly long after the discovery of Neptune itself. And so it's been known for a long time, and that makes sense because it's huge. It is, in fact, almost like a twin of Pluto. This thing is pretty huge. It's one of the biggest moons in the solar system, and so it's definitely kind of interesting here that you know the two of the biggest moons here, Ganymede, which orbits Jupiter, and Titan, which orbits Saturn, and another giant moon, Triton, orbits Neptune, which is a considerably smaller world. It's an irregular moon because it orbits not in the direction the planet rotates. It orbits the wrong way. So that is suggestive that it did not form in this spot. Now, there is the possibility, for example, that it used to go in the correct direction and some titanic or massive upheaval happened in the Neptune moon system that made it go around the other direction. Again, there was some speculation that Pluto used to be a moon of Neptune that got kicked out. That speculation comes from the fact that Pluto's orbit actually comes closer to the Sun than Neptune for about 10 years or so out of its orbit. But that's considered nowadays to be unlikely. Most likely, it's the other way around. Pluto and Triton both formed as icy planetesimals. Pluto got caught into an orbit here that's synchronous with Neptune's orbit, and so they never actually get close together and got kicked out into a very, very elliptical orbit, inner edge of the Kuiper belt. And Triton, on the other hand, got caught in orbit around Neptune. That's considered a little bit more likely scenario nowadays, though that's still uncertain. Remember, only one spacecraft has ever been out to this world and seen this moon, and it did not really study Triton all that closely, not as well as the moons of some of the other worlds had been discovered for various reasons we talked about before. It's geologically more active than we expected. We expected this far out from the Sun to be completely dead, but we do have this cantaloupe terrain. There's markings on the surface. Clearly, craters have been eroded and filled in and wiped away by geologic activity. This is almost what you would expect if you had melting in the world that caused material to come out to the surface and then freeze. Now, this far from the Sun, we're not talking about molten rock. We're talking about what we normally consider frozen stuff, like ices coming out. And this far from the Sun, it's not even water ice. It's like methane ice, ammonia ice, even nitrogen and oxygen freeze at these temperatures. And so even those things are frozen solid and can become ice. And so you heat them up and they can come out on the surface as liquid and then freeze. So that's more likely what was happening here. Again, it does so show geologic activity, and geologic activity that's not incredibly old. Had all this material, all this activity happened a very long time ago, then later meteorites would have hit and created craters in that cantaloupe terrain, and so you would see a lot of craters in there. We don't. We see a few. A very few craters are visible in there, but very few indicative that this cantaloupe type stuff, whatever caused it, has happened in the geologic recent time. Really interesting thing is, even though Titan was discovered way back in the 1800s when the planet was first discovered, it was really not given a name. It was just the moon of Neptune. It was Neptune's moon, or the moon of Neptune. And so informally, they called it 2 or 3 different things, and then they eventually started informally calling it Triton. And that name really did not become official until the 20th century. And it became commonly used in the 1930s, and so by the 1940s, it became the official name. It orbits 23 degrees with respect to the equator, so it's not over the equator like the other moons typically are, and it's a retrograde orbit, so it goes around the wrong way. So that makes it kind of weird. Again, this is why we think it's a captured moon. It is the 7th largest moon in the solar system. There are 6 larger moons, including our moon, which is somewhat larger. Not a lot larger, but a little bit larger. So there are some other big moons out here, but again, it is the biggest moon of Uranus and Neptune by far. So typically, the smaller the world, the smaller the moon. Our moon is weird, but again, we think there's a weird reason for our moon, the impact model. Then the other moons, the other 5 big moons that are out there are moons around Jupiter and Saturn. So that makes it unusually big for Uranus and Neptune. Again, this is consistent with our idea that it's a captured. The orbit does not fit with how we normally think that moons should form. It's similar in size to Pluto and Eris, and there are some interesting ways that it could get captured into an orbit like this. So when Jupiter and Saturn migrated and caused Uranus and Neptune to migrate, that may have been when it got captured. It may have been captured at a later time. But the current idea, the current leading model is that it's captured. So when I was young and first started learning astronomy, or even when I was a kid and learning astronomy, there was some speculation at that point that Pluto was a moon lost by Neptune. And now we think that's entirely not at all the case, that instead Triton is something like Pluto that got captured by Neptune. So, makes an interesting world to study. Again, the Cantaloupe terrain, we're not entirely sure what caused the Cantaloupe terrain, but our best guess is that it has something to do with what's going on under the surface, cryovolcanism stuff moving out, freezing, or moving under the surface and fragmenting, and so forth. So the surface may be heating up and partially melting and moving together. There are these smooth plains, like you see in the left-hand image there. Those smooth plains are probably from some kind of impact and lava flow. Now, at this point, when I say lava, I don't necessarily mean lava like you know it, because this moon's probably too small for molten rock. A hint is that the Voyagers, looking back at Triton, saw a tiny hint of an atmosphere. Now, this atmosphere is super, super, super thin. It is way thinner than the atmospheres of anything else we've talked about in terms of moons or whatever. But the fact that it's even anything there at all was a little bit of a surprise. The atmosphere is about 70,000 times thinner than Earth's atmosphere. It's mostly made of nitrogen with tiny bits of methane and ammonia. The temperature is actually below the freezing point of nitrogen, so that makes it very interesting. So this may be nitrogen that's sublimated, or it could also be a result of cryovolcanism. And so that could release nitrogen gas, which then hangs around for a slight little bit before it freezes onto the surface. The lack of impact craters, the complexity of the Cantaloupe terrain, and the smooth plains all suggest cryovolcanism is in fact a dominant factor on Triton. But it's not just cryovolcanism. We think it's more like cryogeysers. So sunlight hitting the surface of Triton may penetrate below the surface. So sunlight penetrates below the surface, heats solid nitrogen, and it becomes under pressure a liquid, and maybe even a little bit of gas when the pressure is released, and it spews upwards like giant geysers, and so you have a mixture of liquid and gaseous nitrogen coming out. The nitrogen liquid might freeze and fall down like snow onto the surface, and the gas is spread out, forming that super thin atmosphere before they freeze to the surface also. So that may be what's happening. Again, we don't know for sure, but this is kind of our best guess as to what's going on with Triton.